Now in the previous lecture, we have implemented breadth first search algorithm for single source short path problem in case of adjacency list. Now in this lecture, we are going to implement same algorithm for adjacency matrix implementation. Now as we mentioned before, the first thing that we are going to do, we need to add parent property in the graph node. So as we did before, we are going to add it over here. So as you see, we have already added over here. So this part of code is same as the one that we have discussed in our previous lecture. So that's why I'm not just going to go to the details of this from the previous lecture and pass it over here. So basically what we are doing over here is we are just adding this part of code over here in which we are going to save the parent of given node over here. Now the next thing that we are going to do, we are going to create our method inside graph class. So inside graph class, before creating BFS method for single source path problem, the first thing that we need to do, we need to create path print function over here. So this part of code also is the same as the one that we created in our previous lecture. So that's why I've just copied it from the previous lecture and passed it over here. So basically what we are doing over here is we are checking that if node's parent is not null, we are calling this method recursively for the node parent until we have reached the one that in which the node's parent is null. So in this case, we are starting to print out the names of node to the console. With this, we can easily print out the path for a given node based on their parents. So the next thing that we are going to do, I'm going to create the main method, which is BFS method for single source short path problem. So it's going to be like this: public void BFS for single source shortest path problem. So this method will take as a parameter type of graph node. So it's going to be node. So we are going to use Q data structure in this method over here. So as we said before, in case of breadth first search, we are doing an extra step over here. We are just adding the adjacent vertices nodes of parent. So in this case, it's obvious that the first thing that we are going to do, we are going to create Q data structure. So this Q data structure will be the type of graph node. So it's going to be graph node. So here as a Q data structure, we are using linked list. So because in case of linked list implementation, if we use add method, it acts like in Q method. If we use remove method with the index of 0, it acts like the Q method. So that's why it's very easy to use it based on this linked list class over here. So it's going to be the name of Q and it's going to be new linked list class like this. Then the first thing that we are going to do, we are going to enqueue this node to this queue over here. For enqueuing a node to this queue over here, in case of linked list, we are going to use add method. So it's going to be like this, add node. Now then, the next thing that we are going to do, we are going to check that while queue is not empty, we are going to dequeue the element from the queue and we are going to mark it as visited and we are going to print out the path to the console. So it's going to be like this. While queue is not empty, in this case, we are going to create a new node over here in which we are going to save the node that comes out from the dequeue method. So it's going to be the current node. So it's going to be set the queue remove with the index of 0. So if we call remove method with the index of 0, it's going to dequeue the first element from the queue. So then after getting this node, we are going to set the isVisited property of this node to true, because in this case we are setting it as visited. Then we are going to print out path for this node over here. So that's why I'm just going to put the message like this: system out print. So I'm going to put message printing path for node. So let's concatenate the node over here. It's going to be the current node.name. Then I'm going to concatenate it with the two dots over here. So after this one, we are going to see the path. So to see the path, we need to call the path print method to print out the path from the given node to this node over here. So it's going to be like this: print path with the current node. So here we just need to put the name of node. Now after doing so, I'm just going to put println function over here to have next paths in a new line. Then after doing so, we are going to look for the neighbors of this current node over here. So in case of adjacency matrix, we don't have any neighbor list inside this graph node over here. In case of adjacency matrix, we have created a method, separate method, which is responsible for getting neighbors in this case. So as you remember, in our one of previous lectures, we have created a method which is responsible for getting neighbors of given node. So in this case also we are going to use this method over here. So to use that method inside this BFS method, the first thing that we are going to do, we are going to create temporary array list in which we are going to save the neighbors of given current node. So it's going to be like this: array list with the type of graph node. So I'm going to name it neighbors. So it's going to be like this. Get neighbors with the parameter of current node. Now after getting the neighbors, we are going to loop through the neighbors and check that if it is not visited, we are going to add it to queue and we are going to mark it as visited, and we are going to set the current node to the neighbor's parent. So it's going to be like this. For graph node neighbor in neighbors, we are going to check that if neighbor is not visited, in this case we are going to add this neighbor to the queue. So I'm just going to use this queue add method. So it's going to be neighbor. Then we are going to mark neighbor is visited as true, because this is preventing the repetition addition of the nodes to the queue. Then I'm going to set the current node to the neighbor's parent. So it's going to be like this. So with this we can easily track the path that comes to this current node over here. Now with this we have successfully implemented our BFS method for single source short path problem in case of adjacency matrix. Now let's see how this is working in practice. So as you remember, when we are discussing single source short path problem, we have discussed it on this graph over here. So in the last lecture we have created this graph over here. So I have just copied this part of code from the previous lecture. So that's why I'm not going to go to the details of this one also, because here we are just creating nodes and adding this node to this node list. So based on this node list, we are creating a graph. Then we are adding the edge that we have between nodes over here to this graph using add undirected edge function, because in this case, this is not directed graph. Now after doing so, I'm just going to run our code to see the path that if they are the same that we have discussed before or not. So you see that it's printing out the path like this. So here again, we are starting from the node of A. So from A to A, it's A. From A to B, we can go AB. From A to C, we can go AC. So for example, from A to F, we can go A, B, D, F. So as you remember, this was the result that we get when we are doing dry run on this graph over here. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented BFS method for single source short path problem in case of adjacency matrix. So hopefully everything is clear about this method also. Now in the next lecture, let's see what's the time and space complexity for breadth first search algorithm in case of single source short path problem. So see you in the next lecture.